Myself, Berilda, Assistant Professor in the Department of Artificial Intelligence and Data Science at Sri Muthukumaran Institute of Technology. Today I am going to take 3D printing and design. The subject code is CCS 331 Regulation 2021. In the previous video we have seen the design consideration. Today in this video we are going to see some of the printing processes. So first of all, we are going to see about fused deposition modeling. Fused deposition modeling is a 3D printing is also known as fused filament fabrication. It is an additive manufacturing process. This FDM builds parts layer by layer by selectively depositing melted material in a predetermined path. It uses thermoplastic polymers that come in filaments to form the final physical object. This FDM is the most widely used technology across most industries and likely the first process you think of when 3D printing comes up. How does this FDM 3D printing work? An FDM 3D printer works by depositing melted filament over a built platform layer by layer until you have a completed part. FDM uses digital design files that are uploaded to the machine itself and translates them into physical dimensions. Materials for FDM include polymers such as ABS, PLA, PETG and PA, which the machine feeds as threads through the heated nozzles. We can see this in a diagram how it works. To operate an FDM machine, you first load a spool of this thermoplastic filament into the printer. Once the nozzle hits the desired temperature, the printer feeds the filament through an extrusion head and nozzle. This extrusion head is attached to a 3-axis system that allows it to move across the X, Y and Z axis. The printer extrudes melted material in these strands and deposits them layer by layer along a path determined by the design. Once deposited, the material cools and solidifies. You can attach fans to the extrusion heads to accelerate cooling in some cases. So next process is SLA, that is stereolithography. It is one of the earliest and most precise 3D printing technology. It works by using a UV light source, that is a laser, to cure and solidify a liquid photopolymer resin layer by layer. SLA uses UV light to solidify liquid resin, producing high detail, smooth and precise 3D printed objects, making it ideal for applications where accuracy matters most. It gives high detail prints. Some of the key characteristics of SLA is very high accuracy and fine details. It gives smooth surface finish, is often better than FDM print. It's ideal for complex geometries and intricate designs. It uses liquid resin, not filament or powder. Next one is selective laser sintering, that is SLS. It is also an additive manufacturing technique. It uses powdered materials fused by a laser. It is used for a strong and complex geometries. This selective laser sintering is a powder-based 3D printing technology that uses a high-power laser to fuse fine material powders into solid parts layer by layer to build a 3D object. How this SLS works? A thin layer of powder is spread evenly across the build platform. A laser scans the cross section of the part and heat the powder just enough to sinter the particles together. Sinter means bond the particles together. The platform lowers slightly and a fresh layer of powder is spread. Repeat the above steps until the part is fully built. The finished part is buried in loose powder which supports overhangs during printing. Some of the key characteristics of SLS. It uses powder materials, no support structures required. Here powder acts as a support, produces strong functional parts. Finally, it's suitable for complex internal geometries. The next process is direct metal laser sintering and selective laser melting. Both processes are 3D printing technology that melts metal powder and fuses the powder with a laser. This DMLS and SLM are metal powder bed fusion 3D printing technologies used to manufacture fully dense high strength metal parts by using a high power laser to process fine metal powders layer by layer. This is used for metal parts in industrial applications. The basic working principle is a thin layer of metal powder is spread on the weld platform. Metal powder means stainless steel, titanium, aluminum, etc. A high energy laser selectively scans the layer based on a CAD data. The laser heats the powder to bond it together. Then the build platform lowers and a new powder layer is spread. The process repeats until the metal part is fully formed. The key characteristics of this DMLS and SLS are uses metal powders, works in an inert gas atmosphere, requires support structures, then produces complex, lightweight, high performance parts. The difference between this DMLS and SLM are the abbreviated form of DMLS is direct metal laser sintering and for SLM a selective laser melting. The powder fusion is partial melting and solid state diffusion in DMLS, complete melting of powder in SLM. Regarding density, in DMLS, it's high, approximately from 95 to 99%. In SLM, it is very high, approximate to 99.9%. The material used are metal alloys in DMLS and pure metals and alloys in SLM. Regarding strength, it's very high in DMLS, comparable to wrought metal in SLM. So these are about the processes. In the next video, we can see about binder jetting and concept of slicing in detail. Thank you.